Welcome to an Innova Systems webinar. My name is Sam Bromley and I'm going to show you how to use a technique called the master model technique. So before we start showing you in SolidWorks, I want to briefly explain what the master model technique is. So as you can see here, we've got a few key points and also a diagram which should explain this. Now the best way obviously for me to show you is in SolidWorks, but before we start with that, let's just run through what we can see here. So, a master model can control large amounts of geometry. The master model is the controller of any child components that are created from the master model. So as you can see here, we do have a hierarchy. At the very top we've got this model that's been created, which is the master. And the idea with that is that we insert that part, that master model, into a new part, and we create components from it. So both the blue and the red have been created from the same original geometry, but both outcomes are very different. We've got a baffle of a speaker here and the main body. And what we can do here is we can ensure that these components have references to the original master model. So if the master model were to change, those changes would propagate through into the child components. So this technique is very useful for a process which would be utilising a large amount of standardised items with small alterations to the geometry. So we can control the mass geometry, whereas small alterations are done at a different level. So just a few key points I'm going to point out here. So we have overall control with one master model. Large amounts of standardised models can be created and then altered. Alterations to the model are added to the child parts that are created, and there are two main approaches: a surface approach and a solid approach. Now I'm going to show you both these approaches. But first off, we're going to start off with the surface approach. So I'm going to move over to SolidWorks. And as you can see here, we've got a master model. And it's basically a group of intersecting bodies, of surface bodies. And what I'm going to do with this is I'm going to then go about creating those child components from this. So to do that, I'm going to start a new document. I'm then going to insert that part we've just had open into this new document. Now what we can see on the left hand side is the insert part dialog box. Now all we're really bothered about here are the bodies, be them solid bodies or surface bodies. Anything else can be unticked, not really too important. Now I'm not going to locate part, I'm not going to click and place this anywhere. I'm actually going to go to the top left hand corner, I'm going to hit the green tick, and that will position the master model to the same position as my origin of my new part. Meaning that my planes run through dead center through my geometry. Okay, so next what I'm going to do is I'm going to use some surface tools to start creating some enclosed volumes. Now this isn't exactly what we're going to be showing here. There is a small amount of setup with surface tools to then go about showing you the real technique with the master model. So I'm going to go to surface tools. A few of you might be familiar with the surface tools. I will be using a few very simple tools here, but I will explain what they do also. First off, I'm going to use a knit surface here. That basically means that I can select two individual surfaces and make them one body. Pretty simple. That is now one body. I'm then going to use the bodies that I've got here with a trim surface command. Now I'm going to use a standardised trim. I'm not going to use a mutual trim. Mutual trim allows me to trim a lot more surfaces at once. The reason why I'm going to use standard trim is because it makes a much more stable end model for me. So when I make alterations to my master model, those will propagate through very neatly and very tidy. So I'm going to use a standard trim here. So first off I'm going to create the baffle. The baffle is the front of my speaker. So I've selected this surface as the trim tool. And then I'm going to move to remove selections, and that will allow me to trim against that tool. Now I'm going to keep going through this here, making many trims. The idea is that I'm attempting to create an enclosed volume. So I don't want any overlapping edges or faces. And I also don't want any open faces either. So I'm going to keep running through this model, removing edges, and I will end up with quite a few trim commands, but that's not too much of a problem. The end result should be exactly what I want. Now after this selection we should start seeing this to take shape a little bit more, which it certainly is. Still a few more trim commands that I need to do here. Creating the holes, the centre there. Removing a large amount of those circular extrusions. And I'm nearly there. I'm just going to start trimming away a little bit more information. And then finally, after this trim, should just be one more trim that I need to go about creating. Just this one here. Okay, so what I've now got is what we call an enclosed volume. I've got no open faces and I've also got no overlapping edges or surface bodies. So with that now, I'm then going to start a knit surface command. So similar to what I did initially, is I can then decide that all these bodies are going to be 1. And if all bodies are 1, I have the option to try and form a solid. So I turn a surface model into a solid model. Hit the tick to accept. Now, I'm going to save this out now. So I'm going to save as. This is going to be called speaker baffle. I'm then going to repeat that process. So a new part, insert the master model, and this time I'm going to create the other component that I'm intending to create. Same process, start trimming away. There's a lot less trims that I need to go about creating this time. So trim tool is going to be here, and I'm just going to go through removing all this information. Any bodies that I don't necessarily need, I can just hide them. I don't have to delete them or trim them. I can just hide them away. And that's often the case with a lot of surface modelling that we do. We can just hide away particular bodies. Likewise, I can do the very same with these individual circular extrusions. I can merely just hide those away. Final trim now, I'm going to use that as a trim tool and just remove this face here. And what I've got again is an enclosed volume. I'm going to knit these surfaces together, and if I've got no open faces or no overlapping edges, I can again try to form a solid. A little bit more work needs to be done to this. I'm going to shed it out because obviously we're going to have internal components here. Shed it out like so. And with this, I'm then going to go about creating an assembly. Now I need to save that as speaker main. Okay, so I've got a main derived component, and I've got the baffle. So speaker main, I'm just going to hit the tick. Similar to when we inserted the master model, I can just hit the tick there, and that position that to the origin. Likewise, do the very same with the speaker baffle. And this is when I start showing you really why we use the master modelling technique. So to do that, what I'm going to do is I'm going to tile my windows here. To the left hand side we're going to have the master, and to the right hand side we're going to have my new assembly. So let's make some changes to the master, and because we've got an external reference, as we can see here by this arrow, to our master document, any changes I make here should propagate through to the individual components in my assembly. So let's make some changes. Let's change that to 45, let's say, and that to 25. And maybe change that to 20. To rebuild the master model, let's look at the changes that have been made there. Quite dramatic changes. If I now go to my assembly, it'll update, it'll rebuild, check the graphics out, they should change. They've all updated. So, this speaker here, let's say this is going to be called our, we'll save this assembly, and we're going to call this our speaker wireless. I'm then going to put in a hole in the rear of the speaker, and that's going to be for a cable that might go through the very back of my speaker. And then I'm going to save as speaker wired. So let's get these tiled again. So we'll have that component there, and our master on the left hand side. And in the middle we're going to open up our speaker wireless assembly. So I've made a slight alteration to one of my models. I've put a hole in the back, whereas you'll see that in my other assembly there is no hole. Let's make some alterations to the master model. And we'll set that to 25. So let's rebuild this master model now. You see the changes have been made. If we now go back to our assemblies, they will rebuild. See the changes are made. The master model is driving the gross geometry, and the hole in one doesn't exist in the other. So with a slight alteration. So that's the surface modelling approach. I did mention we're also going to look at a solid modelling approach, and we're going to have a look at that now. I'm just going to close these down. So what we've got here is actually a main body for a plug socket. It's hollowed out. And what I'm going to do is I'm going to show you a few tools here to save out bodies of a solid master file. So first off, I'm going to split this in two, because there are going to be two bodies for this particular component, both the back and the front of the plug. I'm going to select the plane which intersects. I'm then going to hit split. Cut the part, the resulting bodies, the front and the back, and hit the tick to accept to save those. I'm also going to double click here. That allows me to save out those individual bodies. So, plug front, and plug back. I'm going to accept that. Creates those bodies for me, creates those parts for me. It'll go back to the master model. You can now see we've got two individual split bodies. We've also got the individual bodies themselves saved into parts. There's an external reference here which is referencing back to the master model. There's also an indicator here of something called a stock item. Stock item is basically a copy of the original body, and it also shows that there's a link between the two. So what I'll do is I'll go back to the plug master, and with those bodies that we've created, we're now going to create an assembly, much like we did with the service body. So I'm going to start a new assembly. Plug back, tick, and also plug front. And I'm going to put the holes to the front of here. The reason why I chose the plug is because a plug is quite a standardised item in regards to its enclosure, whereas the pins themselves may change in shape, orientation or size, depending on what country you're using that plug in. What I'm going to do is I'm just going to create a very simple set of holes here. I'm not going to worry too much about definition, only reason being is just so for time here. So that's going to be my UK plug, we're all familiar with that. I'm going to extrude cut through that geometry. And I'm going to save that as plug UK. I'm then going to delete that feature and that sketch. Start a new sketch on here. And I'm going to do some circular cuts instead. I'll add a certain amount of definition here just so they are more uniformed. And I'm going to do an assembly level feature and cut through the face again. And I'm going to save this as plug Spain, for example. I'm not sure if they use round pins in Spain, but plug Spain, that'll do. Save that. And I'm going to do a similar process to what we did before. I'm going to tile these so we can see them change. So our master model over here. I'm also going to open up plug UK. That can go in the middle. So you can see, again, very similar to the service model, we've got them tiled here. We've got slight alterations to individual plugs. And if I now change the solid bodied master for the plug, let's make some alterations to it. And rebuild that. Changes are made there. If we now go into the plugs, those changes are made to each individual body. So I'm showing you there two different ways: a surface model, which might be a master document, and then likewise a solid master. Both those techniques are very similar, but just a few different techniques and tools that we might use to each one of those different types. So as you can see with this process, we can control the mass geometry of a generally standardized set of models, and this process can be implemented to drive a range of models, making small alterations to geometry only to the individual saved out bodies. So gross geometry can be controlled by that master document, and that is essentially the master model technique. So I just want to thank you for watching. We always do a webinar every Thursday at 10 o'clock, so please do feel free to check out the website and register for those webinars. So I hope this has been useful to you, and I hope that you've seen something that you can implement into your model processes, and thank you for watching.